you've mentioned something called a super antigen, and you talked about the furin cleavage site. What does that mean exactly? What is a super antigen, and why is it dangerous to us? And it seems to be present on SARS-CoV-2.
So the superantigen is something that can activate our T cells non-specifically. So any T cell, not any T cell. So a T cell that's not specific to the virus, if it's in proximity to viral antigen, and namely the superantigen, if it's near, it can interact in a way. I think the superantigen will kind of link and stimulate, be able to send a ligation signal to the T cell receptor on the CD8 T cell. And that will make the CD8 T cell think that it's seen the viral sequence or the cancer sequence or what have you. It makes it think and believe that it sees the sequence that it's specific to. So that T cell will act. And when it's a CD8 T cell, what acting means is basically killing. So it'll be non-specific activation. So when you get a lot of non-specific activation, you can end up getting a lot of damage. And I think that's exhibited well by MISC. The syndrome of non-specific T cell activation mediated by the superantigen. Now they say it's very delayed, it's a delayed syndrome, and it is, but that delay may be because the antigen is in the gut and it's relatively shielded, and it takes a while for the immune system to see that antigen. But when the superantigen is in the lungs, and ORF8 may also be superantigenic, you'll get some more non-specific T cell activation. And that recent German paper out of Germany, I think it was in Cell. It shows that complement is also activating the T cells non-specifically. Now, I knew I was seeing non-specific T cell activation because no virus was going to do that we were looking at whole blood, not even T cells that were specific to the virus. When you look at, in infection, it looks like so many of the T cells are stimulated. And I knew that, that was a sort of non-specific activation going on. I thought predominantly it was the superantigen. It may still be superantigenic stimulation, but it looks like complement is also doing this, which is very interesting, a very big finding. And I wish I kind of had all the mechanism right, that it was also complement activation, non-specific activation of the T cells. But I find the new paper very compelling, and I think it's a great addition to understanding the immunopathology of the infection.
I guess it would explain why some of the immune modulating drugs work, like tocilizumab and baricitinib too. One thing is so the superantigens can activate like a huge portion of your T cells versus a natural infection. Like, a natural infection gets you like 0.1 or 1% of your T cells. A superantigen can activate like 20, 30, I think 100%, right, of your T cells. Is that right?
Yeah, so anti-CD3 is like an antibody that you can use, and that will activate it's a superantigen, sort of. That'll activate all your T cells. So yes, you can activate a high amount of T cells with superantigen. And I wonder what proportion of the T cells will be able to be. I think it was but yeah. Okay, just a lot. Like let's say 70-80% for. I don't know how many for the SEB superantigen specifically, but
I think it's 20% for that one.
Oh, it is? Yeah, the evidence is there that there's a lot of non-specific activation. And when you have that, you're going to have non-specific cell killing mediated by the T cells. And so you kind of want to, if you're going to target that for therapy, you kind of want to hold those T cells back in a way, especially if it's a person with a highly differentiated repertoire and a low amount of naive T cells, because those naive T cells are going to soak up some of the signal. There's a concept in immunology, in T cell immunology, called cytokine sinks. And what that is specific, certain T cells or certain immune cells will act as sinks for other cytokines and signals. Now, here's the thing. So that CD95 and the CD95 ligand, those aren't cytokines per se, but naive T cells will act like sinks for it's CD178 for the Fas ligand. So what they'll do is they'll take up that differentiation signal. So when those naive T cells are around to take up that differentiation signal isn't happening to the T cells that are differentiated enough to actually become highly cytotoxic. So you can end up dampening physiologically. Well, this is just how it works. The physiological system of effector acquisition is dampened by the CD95 expressing, younger T cells. When they're naive T cells, they don't express CD95. That's actually what we call T stem cell memory. Those will start expressing CD95. They'll soak up that signal almost like a cytokine sink and prevent a high amount of effector differentiation. And I tried to illustrate that in the that one paper that I published earlier. I think I'm writing another one right now, and I'll more clearly explain this whole system, because it's not something that was entirely relevant to cancer immunotherapy. I mean, it was published a little bit about it, but the implications for infectious disease and quorum sensing of T cells were not published upon. I went back to medical school and I got busy. So I'll
it's kind of like carbon in a nuclear reactor, right? Like it sort of absorbs, the stuff that might cause a runaway reaction. Would you say that's a good analogy?
That's a great analogy. I wish I had thought of it.
So basically, if you're older, if you have more differentiated T cells, because your T cells, you've been around longer and you fought off more diseases and more cancers in your body, your ability to absorb and survive the massive activation of your T cells caused by SARS-CoV-2 is a lot less. Basically.
That's a fantastic summary. Yep.
So that's, you've explained basically why older people get much more severe disease with SARS-CoV-2.
I can explain it in part by this mechanism. I believe it's theoretical. I mean, I've shown the mechanism in vitro. It's been published, but it has not been applied specifically to infectious disease. And I need to work on that and publish. I know I told you that I wanted to, maybe get less Twitter cred and more publications, because that's what I need at this stage, don't I? But I knew that I wanted to help you. I know that you're a frontline worker, and I wanted to help everybody else. So I want to explain this before I do go on and publish it, because you guys are very deserving of it.
No,